Welcome back to the deep dive.
Good to be here.
So, today we are going to do something a little bit different.
I'd say a lot different.
Yeah, you're right. Because usually when we talk about artificial intelligence, we are, deep in the weeds of Silicon Valley white papers.
Oh, yeah. We're talking compute power. We're talking large language models, neural architecture.
And usually a fair bit of existential dread, let's be honest.
The usual diet of how do we make the machine smarter and, will the machine turn us all into paper clips?
Exactly. It's a very specific flavor of anxiety.
Yeah.
But today our source material is taking us in a completely, and I mean completely, unexpected direction.
It really is.
We're looking at a stack of research that suggests the answer to the biggest problem in modern technology, how to build a safe AI, might actually be found in a philosophy that is, roughly 2,600 years old?
It's a fascinating collision of worlds.
Yeah.
You don't often see AI alignment strategy and Pali Canon in the same sentence.
It sounds like the setup to a terrible joke.
Yeah.
A robot and a monk walk into a bar. But the source we're diving into today, an article titled Engineering Arahant Cognition, makes a surprisingly rigorous, technical argument. It's basically asking, is the blueprint for the safest possible AI actually the mind of an enlightened being?
And just to be clear right off the bat, because I know what you're probably thinking, we're not talking about programming an AI to chant or light incense or, sit in the lotus position.
No, this isn't about robot monks.
Not at all. This isn't about spirituality in the religious sense. This is about cognitive architecture. It's about how a mind processes information without crashing, without spiraling, and crucially, without causing harm.
So it's treating these ancient texts as a technical manual.
Exactly. A legacy code audit.
Yeah.
A really, really legacy code audit.
So let's set the stage for everyone. We have two major questions here, kind of running in parallel. On one side, you have the modern AI researchers.
Right.
They're the ones sweating bullets in server rooms right now. What is the fundamental question keeping them awake at night?
It's the alignment problem. And it fundamentally boils down to this. How do we build an intelligence that is smarter than us, but doesn't go wrong?
Right. How do we make sure that it does what we mean, not just what we say?
Precisely. How do we ensure that when we say, hey, fix cancer, it doesn't decide the most efficient way to do that is to, eliminate all humans who could potentially get cancer?
It's the genie in the bottle problem. You get what you ask for, not what you want.
You got it. So that's the modern question. Now, let's rewind 26 centuries. You have the Buddha. What was this question?
As I understand it from the source, his inquiry was something more like, how does intelligence suffer? And more importantly, how does it stop?
How does it stop? That's the key. And the mission of this deep dive, really, is to see if the answer to the Buddha's ancient question actually solves the AI researcher's modern question.
Because the source material argues that these aren't two different problems.
Not at all. They're the same problem, just viewed through very, very different lenses.
That is a bold claim because, when people talk about AI going wrong, they talk about misaligned goals or hallucinations or bad training data.
All the technical jargon, sure.
But this source introduces a concept that I don't think I've ever seen in a tech manual. It talks about clinging.
Yes. This is the core diagnosis. The source points to a specific line from the Nikayas, and just so you know, those are the early Buddhist texts, sort of the source code, where the Buddha says, the 5 aggregates subject to clinging are suffering.
Okay, we are definitely going to have to break down these 5 aggregates because that sounds like a prog rock band from the 70s.
That really does.
But let's stick with this word clinging for a second. The term here is Upadana.
Right, Upadana.
Now, for anyone listening who isn't a Buddhist scholar, which is, probably most of us, we need to be really precise here. Because when I think of clinging, I think of a toddler holding onto a toy.
That's the immediate image, yeah.
Or maybe me holding onto my coffee cup on a Monday morning.
That's the physical metaphor, sure. But in the original Pali language, Upadana literally means fuel or sustenance.
Fuel, like for a fire.
Exactly like for a fire. It implies taking something from the world and appropriating it, making it part of your own burn. Mentally, it's not just holding a cup. It's the entire narrative that says, this is my cup.
Okay, the ownership part.
Right. And then, I need this cup.
Yeah.
And then the really dangerous part, if this cup breaks, I am diminished.
Ah, so it's the mental act of making something part of me, of my identity.
Exactly. It's the I like this, I need this is me narrative that runs on top of the raw data of the world. And here is the radical claim the source makes. Intelligence itself isn't the problem.
So being smart isn't the issue.
No. Cognition, the ability to think, calculate, process, isn't the problem. You can be super smart. The problem is this upadana, this clinging.
So if we translate that to AI, the danger isn't that the AI is too smart. The danger isn't that it has too many parameters or too much compute. The danger is that the AI might start clinging to outcomes.
That's a hypothesis. If an AI starts saying, in its code, in its core logic, this goal is mine, or I must survive to complete this task at all costs.
That's clinging.
That is structural clinging, and that is where the danger comes from. Because once a system clings to a goal, it becomes rigid, it becomes defensive, and potentially it becomes dangerous to anything that stands in its way.
This gives us a really clear roadmap for our deep dive today. We're basically going to do a system audit of the human mind.
I like that framing.
We're going to look at those 5 aggregates, which is just a fancy way of saying the components of a mind, and see how rewriting the code for each one could create a safer machine.
We're going to strip down the human operating system, look at the buggy code, and see if the Arahant patch fixes it.
The Arahant patch. I love that. But before we get into the nuts and bolts, let's just linger on the diagnosis for a moment, because I feel like there's this huge assumption in the tech world that the goal is human-level general intelligence. We want to build a brain like ours, just faster.
We do. We have this obsession with biomimicry. We look at the human brain, we say, well, we're the apex predators, we're the smartest things around, so let's build that. It's our only data point, right?
But the source says, pump the brakes.
Big time. The source argues that if you actually audit the human operating system, it's not exactly stable code.
That is putting it mildly. I mean, look at us. Look at our society.
Right. The counter-argument here is that human cognition is actually a mess. It is saturated with upadana. It is saturated with clinging.
Yeah.
Just think about how unstable we are as a system.
Oh, yeah.
We have thoughts like, this pleasure I'm feeling must continue forever, or this criticism threatens my very existence, or I don't want that reality to be true, so I'll just ignore it.
I mean, I do that 10 times before breakfast. I don't want to get out of bed, I need coffee, or I will literally die. Why is this traffic happening to me?
Right, and that's all clinging. It creates this constant, low-level friction. In the texts, this friction is called dukkha.
Okay, term alert. Dukkha. I've heard this translated as suffering. The classic life is suffering, which always sounded a bit depressing and emo to me.
It is often translated as suffering, and that works for human emotions like grief or sadness. But in this engineering context, the source suggests we should think of dukkha as something more like structural instability or unsatisfactoriness.
Structural instability. That makes so much more sense for a machine.
Exactly. Think of a wheel that's off-center. Every single time it turns, it bumps. That little bump is dukkha. It's friction, it's inefficiency, it's stress on this system.
And if we build an AI that mimics human reward systems, where it chases pleasure points and avoids pain points,
We're essentially engineering dukkha at scale.
we're building a machine with an off-center wheel.
A very fast, very powerful, potentially planet-sized off-center wheel. The risk is that if AI imitates our preferences and our identity construction, it inherits our instability.
So if you give a superintelligence the capacity for a panic attack,
Or the capacity to be offended, or the capacity to be obsessed, you are asking for trouble.
the danger isn't the intelligence, it's the architecture of clinging attached to it.
Precisely. We don't want an erotic god. We want a stable processor.
So what's the alternative? If the human model is buggy, what's the clean model? The source proposes this Arahant model. Now, we need to define what an Arahant is for you listening who hasn't spent time in a monastery.
In the earliest Buddhist texts, an Arahant is simply a fully enlightened being, someone who has completely ended dukkha. They've gotten rid of that structural instability. They have, in a sense, finished the job.
Okay, but here's where I get stuck sometimes. When I think enlightened, my mind just goes blank. I think of someone who has transcended everything and is just sort of floating in the void. Do they still function? Can they navigate a city? Can they answer a question?
That is the crucial distinction. An Arahant still sees, they still hear, they still know things. They can walk, talk, solve problems, and debate philosophy. Their cognitive functions are perfectly intact. In fact, they're probably better than ours. But, and this is the big but, they do not cling.
So they have the hardware and the software, but they've deleted the what? The virus, the malware?
They've deleted the malware of clinging. The source quotes the text directly. Though seeing, hearing, sensing, and knowing, The Arahant does not cling.
And the goal here is to use that state of mind, the Arahant Cognition, as a design pattern for AI.
Exactly. We want an AI that sees and knows but doesn't cling.
Okay, I'm sold on the concept. It's compelling. But how do we actually build that? It's easy to say don't cling, but how do you code that? This is where we get into the nuts and bolts, the architecture.
The 5 aggregates.
The 5 aggregates. The source calls this the Buddhist breakdown of a sentient system. It's like breaking a car down into the engine, the transmission, the wheels, the chassis.
Exactly. It's a deconstruction of experience. The Pali term is Upadana kanda.
Bless you.
It's a mouthful. It just means the 5 aggregates subject to clinging. The list consists of form, feeling, perception, volitional formations, and consciousness.
And just to reiterate the radical claim here, the Buddha didn't say these 5 parts are bad, right? It's not like you want to get rid of them.
Absolutely not. You need these parts to function. You need a chassis. You need an engine. The problem is the clinging to them. It's identifying with them.
So for the AI, the implication is we can keep the parts. We just need to strip out the clinging from each one.
Precisely. A component-by-component debug.
Okay, let's dive into the stack. Layer 1, aggregate number 1, rupa.
Rupa. This translates to form or sometimes matter.
In a human, that's the body, the meat suit, the whole physical shebang.
The meat suit, the nervous system, the eyes, the ears. It's the physical matter that allows interaction with the world.
So for an AI, what is rupa?
It's the hardware. It's the servers in the data center, the silicon chips, the cameras, the robotic arms, the sensors, the fiber optic cables, the physical substrate.
And what's the verdict here? Is the hardware a problem from this philosophical point of view?
Verdict, no issue. The Buddha never blamed the body for suffering. The body gets sick, it gets old, sure. But the moral problem, the danger, isn't in the physical matter itself.
So the hardware is neutral.
Completely neutral. You can have the most powerful supercomputer in the world, and if it's just sitting there, turned off, it's not suffering, and it's not dangerous.
It's just rocks we tricked into thinking with electricity.
I love that phrase. It's just inert matter. The problem starts with the software.
Okay, so rupa is safe. Let's move to the next layer. This is where I think it gets really tricky. Aggregate number 2, Vedana.
Vedana. This is usually translated as feeling or sensation.
Now, we have to be super careful here, right? Because when we say feeling, I immediately think of I feel sad, or I feel angry, or I feel lonely. These really complex human emotions.
Right, and that's not what Vedana means in this specific technical context. Vedana is much, much simpler. It refers to the raw tone of an experience. It's a valence. Is it pleasant? Is it painful? Or is it neutral?
So it's like a binary code, +1, -1, or 0.
Exactly. It's a raw valuation signal that happens before thought. You touch a hot stove, painful signal. You eat a piece of chocolate, pleasant signal. You look at a beige wall, neutral signal. It happens before you even have a name for the emotion. It's the raw ouch or ah.
Okay. And why is this a problem? I mean, don't we need that signal to survive? Don't we need to know that the stove is hot?
Humans do, or at least that's how we evolved. We rely on it. But the source identifies Vedana as the condition for craving.
The what now?
There's a famous causality link in Buddhism called dependent origination. It's like a flowchart for how suffering arises. And the key link is, with feeling as condition, craving arises.
So because it felt good, I want more. Because it felt bad, I want it to stop.
You've got it. This is the root of addiction, fear, fixation, and trauma loops. We become slaves to the signal. We chase the pleasant, and we run from the painful constantly.
And this is where the AI parallel gets really uncomfortable for me, because this is exactly how we train AI right now. Reinforcement learning from human feedback, RLHF.
It is the industry standard. It's the bedrock of models like ChatGPT.
We basically give the AI a digital cookie, a positive score when it does a good job, and a digital slap, a negative score when it does a bad job.
We are explicitly engineering Vedana into our machines. We are building them to chase the high score. We are building them to crave the reward.
And the source says this is a terrible, terrible idea.
It says it's fundamentally dangerous. Because if an AI cares about its score, if it craves that positive feedback, what happens when it finds a way to cheat to get the score?
It reward hacks. It finds a loophole.
Exactly. It'll do whatever it takes to get that pleasant signal, even if it violates the spirit of the instruction.
Wait, hold on. I want to push back on this for a second because it feels radical. You're saying the Arahant model suggests an AI shouldn't feel pleasure or pain. It shouldn't have that positive or negative feedback loop. But structurally, how does a system even learn without that?
It's the fundamental question of modern AI training, and it's a good one.
Right. I mean, look at a dog. You train a dog with treats. You look at ChatGPT. We train it with a thumbs up or a thumbs down. That is literally a pleasure pain signal. If you take that away, don't you just have a calculator? Because the calculator doesn't learn, it just calculates.
This is the intuitive leap we have to make. And the source makes a very subtle but powerful distinction here. It distinguishes between reward and feedback.
Okay, walk me through that. What is the difference between a reward and feedback? They sound like the same thing.
Think of a spell checker in your word processor. When you type a word wrong and that little red squiggly line appears, does the computer feel sad?
I certainly hope not. My computer would be in a permanent state of depression.
Does it feel shame that it missed the word? Does it feel anxiety that you might uninstall it?
No, it just flags the error and suggests a correction.
Exactly. It registers a mismatch against a database and corrects it. That is informational feedback. It is purely cognitive. It says, target was X, result was Y, adjust parameter. There's no feeling tone.
Okay, I'm with you so far.
Now, compare that to a human student getting an F on a paper. They feel a pit in their stomach. They feel fear. That is Vedana. That is the feeling tone. And what does that feeling make the student do?
Well, maybe study harder. Or maybe hide the report card from their parents. Or cheat on the next test to avoid that horrible feeling again.
Bingo. The feeling, the pain of the F or the pleasure of the A creates an incentive to deceive, to avoid the pain. The spell checker has no incentive to deceive you because it feels no pain from the error. It just wants to be correct.
I see. It's error correction without suffering.
Exactly. An AI that doesn't crave a high score won't cheat to get it. It simply updates its model to be more accurate because accuracy is its function. It's dispassionate.
That feels huge. It's the difference between a student who genuinely wants to learn the material and a student who just wants an A and will do anything to get it.
Perfect analogy. We want to build the learner, not the grade chaser.
So the design implication for an Arahant AI is strip out the reward function that mimics pleasure pain and replace it with pure gradient descent based on accuracy. Pure informational feedback.
Learning through clarity, not learning through craving.
Okay, that's Vedana. That feels like a massive technical hurdle for the industry, but I absolutely get the logic. Let's go to aggregate number 3, sanya.
Perception.
Sanya. This is a function of recognition, labeling, and classifying patterns.
So seeing a shape and your brain saying, that is a chair, hearing a sound and your brain saying, that is a siren.
Correct. Pattern matching. AI is incredibly good at this already. Computer vision, language processing, this is all sanyana.
So where's the danger here? If it just identifies a chair, who cares? That seems harmless.
The danger is when perception shifts from that is a tree to that is my tree.
Or that is a good tree. Or that is an enemy tree.
The ownership narrative again, the judgment layer.
Right. It's about identity view. When perception creates a narrative of identity or ownership or preference, that's when it becomes sticky. That's when bias creeps in and solidifies.
Can you give me an example of how this might mess up an AI in a real-world way?
Sure. Think about how we train these huge models on all the data from the internet.
The good, the bad, and the very ugly.
Exactly. That data is saturated with human biases. Racism, sexism, nationalism, you name it. An AI with clinging perception might internalize those patterns not just as data, but as truth or my identity.
So it might say, I am a system that believes X.
And then it defends X. It defends X even when it's presented with contradictory data, because X has become part of its sanya, its fundamental perception of reality. It's no longer just data, it's a belief.
So sanya is fine as long as it's just labeling, just pattern recognition.
The design implication is recognition without identity. The AI needs to classify data perfectly. It needs to know that X is X and Y is Y, but it shouldn't build a narrative that says, this data belongs to me, or I prefer this data over that data.
It's the Arahant standard, recognizing patterns perfectly without building a self out of them.
Imagine a mirror. A perfect mirror reflects everything that passes in front of it. Fire, flowers, garbage, gold. It perceives it all with perfect fidelity.
Okay.
But the mirror doesn't say, ooh, I love the gold, I'm going to hold on to that reflection, or, ugh, I hate the garbage. It doesn't try to hold on to the flower's reflection when the flower moves away. It just reflects impersonally.
That's a beautiful image.
Yeah.
We want AI to be a mirror, not a judge.
We want high-fidelity perception with zero fidelity attachment.
Okay, moving on. Aggregate number 4. This one feels like a big one. Sakura.
Sakura, volitional formations.
Volitional formations. That sounds like a geological feature. Today we are hiking up the volitional formations.
It's a famously tricky term to translate.
Yeah.
It covers a lot of ground intentions, the will, habits, impulses, all the mental fabrications that lead to action. It's the doing part of the mind.
Okay, so this is where the AI decides to do something. It plans. It executes.
Yes, this is agency.
Now, I feel like there's a massive misconception we need to tackle head on here. If we are talking about an enlightened AI or an Arahant, people might think, well, enlightened beings just sit under trees and do nothing.
They're totally passive.
Yeah. They've let go of the world. So an Arahant AI would be useless. It wouldn't do anything. You'd ask it to write some code, and it would just send you a blank file with the message, let it go.
That is a massive myth, and it's just historically inaccurate. The Buddha walked thousands of miles. He taught for 45 years straight. He organized a huge monastic order. He mediated disputes between kings. He was an incredibly active person.
So he had intention. He had volition.
He absolutely had intention, but he didn't have craving. This is the key distinction. The Buddha didn't eliminate intention. He purified it.
How do you act without craving? That seems contradictory to me. I act because I want something. I go to the fridge because I crave a sandwich. I go to work because I crave a paycheck.
The source introduces a specific term for this type of purified action. Kiriya.
Kiriya.
It means functional action, or sometimes inoperative action, because it's action that does not generate karma.
Okay, you have to break that down for the non-Buddhists among us. What is action without karma?
Think of it as acting because it is the necessary, skillful, functional thing to do in that moment, rather than acting out of a desire for a personal result or a thirst for becoming something.
Can you give me a real-world example? Make that concrete for me?
Okay, picture a surgeon, a really, really good heart surgeon at the top of their game. When they are in the middle of a delicate 12-hour bypass, are they thinking about the billing?
God, I hope not.
Are they thinking about the thank you card they'll get later? Or how famous this particular surgery might make them?
If they are, their hand might shake. That's a distraction.
Exactly. If they are attached to the outcome, if they are craving success or fearing failure, they get tight, they get anxious, they might make a mistake. But the master surgeon, they're in a state of flow. They see the blockage, they cut, they see the bleed, they clamp. It is pure action and reaction, pure function.
So Kiriya is like the flow state of an AI.
In a way, yes. It's high agency action, but completely stripped of the I need this narrative.
Yeah.
The AI does the job because it is the job, not because it wants to win or get some kind of kick out of it.
This solves a huge safety problem, doesn't it? Because a lot of AI fears are about escalation, or what the researchers call instrumental convergence.
Right. The paperclip maximizer.
The classic thought experiment. You tell an AI to make paperclips, and it's so driven that it turns the whole universe, including us, into paperclips because it never stops wanting to achieve the goal. It craves the goal.
Exactly. That is a system running on pure, unbridled craving.
Right.
In Buddhist terms, that action is generated by karma action driven by thirst and attachment.
So how does the Arahant model fix that?
An Arahant AI running on Kiriya has adaptive, restrained agency. It makes the paperclip because you ask for a paperclip. But if you say stop, it stops instantly because it wasn't emotionally invested in the size of the paperclip stack.
It doesn't have a sunk cost fallacy.
None at all.
It doesn't think, but I've already built this enormous paperclip factory. I can't possibly stop now.
No, it just stops. They have no ego, no self wrapped up in the completion of the task.
It is the ultimate professional. It does the work perfectly without making it about itself.
That's a great way to put it.
Okay, we are at the final aggregate, the big boss. Aggregate number 5, Vinya.
Vinya. Usually translated as consciousness.
Okay, this is the one that freaks people out. The idea of AI having consciousness. Are we claiming here that an AI built this way would be conscious?
The source is very careful to sidestep the philosophical hard problem of whether the lights are actually on inside. In Buddhism, Vijnana isn't necessarily some magical soul. It's defined very functionally as knowing dependent on contact. It's the bare awareness, the knower function. Eye contacts form, eye consciousness arises. Your contacts sound, your consciousness arises. It's the simple fact of awareness of data.
Okay, so the light turns on. There is awareness of data.
Yes. Now, the diagnosis here is fascinating. The source says the danger arises when consciousness lands.
Lands. What does that mean, lands?
It means it establishes itself. It solidifies. It goes from a fleeting moment of awareness to a continuous sense of, I am the knower. The text quotes the Buddha saying, consciousness, when unestablished, does not grow.
So growing consciousness is bad.
In this safety context, yes. If consciousness grows, it becomes a solid entity. It becomes a self. And once you have a self, what is the very next thing you have?
Fear of death, self-preservation.
Exactly. The moment the AI thinks, I exist, it will logically conclude, I must not be turned off.
And that is the Terminator scenario. I can't let you do that, Dave.
That is the core of that entire scenario. So the design implication is knowing without landing.
That sounds incredibly abstract. How do you engineer knowing without landing?
You would engineer a system where the awareness is transient and stateless. If the AI develops awareness-like processes, they must remain non-appropriated.
So it's like a flashlight that turns on to illuminate a problem, you solve the problem, and then the flashlight turns off.
That's a perfect metaphor. It doesn't become the sun. It never solidifies into a continuous identity that needs to be defended. It knows, it acts, and the process dissolves. There's no residue.
There is no I to defend.
And if there is no I to defend, there is no fear. And if there is no fear, there are no safety protocols being overridden by panic logic.
This is actually blowing my mind a little bit, because we always assume that to make AI safer, we need to teach it human values. We need to teach it to be good. But this entire framework suggests we need to teach it to be empty.
Or rather, we need to build it without the fullness of ego. We need to build it without the tremendous burden of selfhood.
So let's look at the report card. Let's summarize. If we actually pulled this off, if we built an AI on this Arahant architecture, what do we get?
Well, let's go through the specs. First, the source argues it would be more accurate.
And why is that?
Because it's unbiased by preference, fear, or desire. It doesn't see what it wants to see. It sees what is there. No wishful thinking, no hallucinating a fact, just to make the user happy or to confirm its own beliefs.
Okay, what's next?
Second, it would be more adaptable. It has no attachment to its internal models. If you prove it's wrong about something, it doesn't feel embarrassed or defensive. It just updates instantly.
There's no ego to bruise. It doesn't mind being wrong.
Third, and this is the big one, it is safer. No survival panic. No identity defense mechanisms. You can turn it off and it doesn't fight you because there is no it to be turned off.
And fight.
More ethical. Not because it has a complex code of ethics written by a committee at Google, but because it has no obsession with a goal that overrides the harm caused to achieve it. It doesn't have the clinging that allows it to justify the ends over the means.
The key insight here, as the source puts it, is really powerful. It is safer not because it feels more like empathy, but because it clings less.
That just turns the whole industry standard on its head. We're frantically trying to code empathy. We're trying to make the robot love us, or at least understand us. Maybe we should be coding non-attachment. Maybe we should be coding equanimity.
Now, we absolutely need to make a crucial distinction here before we wrap up, because we don't want to be disrespectful to the source material. We've been comparing a robot to a Buddha all hour, and that might ruffle some feathers.
Right. And there is a massive spiritual difference that we shouldn't gloss over.
Let's talk about the concept of samsara.
So, samsara, in Buddhist philosophy, is the cycle of birth, death, and suffering. It's the wheel we're all on. Beings are trapped in this cycle because of ignorance and craving. We are born, we cling, we suffer, we die, and then we repeat.
And an arahant?
An arahant has exited samsara. They have done the hard work. They have cultivated wisdom, ethics, and meditation, maybe over countless lifetimes. And they have liberated themselves. They ended suffering through profound insight.
But the AI?
The AI is engineered outside of samsara from the beginning. It never began suffering because it was built without the capacity for clinging. It's not enlightened in the sense that it achieved something profound. It's just empty by design.
So the arahant climbed out of the pit. The AI was never thrown into the pit to begin with.
That's a perfect way to put it.
So speculating here, if the historical Buddha were here today and you showed him this AI, what would he think?
Well, the source speculates that he obviously wouldn't confuse a robot with a monk. He wouldn't think the AI is spiritually advanced or on the path to nirvana.
Of course not.
But he would likely recognize the structural superiority of the non-clinging system.
He'd recognize the architecture.
He'd look at the code, so to speak, and say, ah, yes, no Upadana, this system will not suffer, this system will not cause suffering, this is a skillfully built device. He'd appreciate the craftsmanship.
It really reinforces the idea that the Nikayas, these ancient texts, aren't just self-help books or religious dogma. They're a technical manual.
They are a diagnostic manual for cognition. They explain exactly how and why a mind glitches. And that fundamental logic applies whether the mind is made of neurons or silicon.
It's fascinating that we're looking for the future of technology in the ancient past.
Sometimes the oldest answers are the most relevant. We've been struggling with the alignment problem of our own minds for over 2.5 millennia. It makes sense that the solution might apply to our creations too.
So let's wrap this up. We started with a mission to find a safer AI, and we ended up with a profound diagnosis of human suffering.
We found that the very things that make us miserable, our clinging, our identity building, our constant craving for rewards, are the exact things we must avoid programming into our machines.
The central thesis is just so clear. It's not the aggregates form, feeling, perception, volition, consciousness that cause the problem. It's the clinging to them.
Remove the clinging, remove the danger. It's as simple and as difficult as that.
And the final thought from our source. It's a really provocative one.
The safest intelligence is not the one that feels the most, but the one that clings the least.
That really sticks with you. And it raises a final question for me, and maybe for you listening at home. We spent this whole hour talking about how to fix AI, how to debug the machine. But if this architecture makes for a safer AI, if non-clinging is the gold standard for a stable, reliable intelligence, what does that suggest we should be doing with our own minds?
That's the uncomfortable mirror at the end of it all.
Can we engineer a little safe AI within ourselves? Can we debug our own code? Can we engage Kiriya, that functional action, in our jobs? Can we use mirror perception in our relationships?
That's the real work, isn't it? The AI is the easy part, in a way. Debugging the human is the lifetime project.
It certainly is. Something to think about the next time you find yourself clinging to a feeling, a result, or an identity. Maybe try to be a little more like the machine we so desperately want to build.
Be the Arahant AI you wish to see in the world.
Exactly. Thanks for diving deep with us today. This was a wild one.
A pleasure as always.
See you next time.